Hello, AP Physics students. Welcome to another physics example problem. Tonight we are going to be working on problem number 57 from chapter number 5. And this problem is about Kepler's third law. All right, so little Kepler's third law example problem here. Okay. And 57 states the asteroid Icarus, though only a few hundred meters across, orbits the sun like the planets. Its period is 410 days. What is its mean distance from the sun? And of course, Kepler's third law states that for any two objects in the universe, in this case, we are going to be comparing this asteroid Icarus and the Earth. But for any two objects that are orbiting the sun, the ratio of their periods squared is equal to their mean distance cubed. Mean distance from the sun cubed. So, for instance, in this example, we're going to be comparing the period, the time it takes Icarus to make one full trip around the sun compared to the Earth, all right? And Kepler's law states that we have to square that, and that will be equal to the ratio of the mean distance from Icarus to the sun to the mean distance, or you can kind of think of it like radius. Keep in mind that in Kepler's laws that, this is the mean distance. But remember, according to Kepler's laws, things orbit the sun in ellipses with the sun at one focus. So it's kind of like a radius, but we prefer the term mean distance to the sun. Okay, well, and the problem was asking what is the mean distance from the sun for Icarus? So this asteroid, what is its mean distance from the sun? Well, what do we know? We know that the period, the time it takes for Icarus to go around the sun, is 410 days, right? It told us that in the problem. Of course, we know it takes 1 year, or 365 days. Notice I'm going to write it as 365 days here. I'm going to write it as the same unit here. I can use whatever units I want for Kepler's third law, so long as the period is in the same unit and the mean distance is in the same unit. Since these are essentially ratios, whether these are years or seconds or millennia, the ratios cancel out, so I can use any units I want so long as they're the same. All right, and we will need to look up the mean distance from the Earth to the Sun. One astronomical unit, it's sometimes called, is 1.5 times 10 to the 11th meters, or about 150,000 kilometers, 93,000 miles. Right? Well, it looks like here we have an equation with 4 variables, and we know 3 of them. So looks like this pretty much just comes down to some algebra. So let's go ahead and get to it. I'm going to go ahead and solve this. Algebraically first, okay? So I'm just going to write this as t sub I squared divided by t sub e squared is equal to r sub I cubed divided by r sub e cubed, right? So if I rearrange this a little bit, r sub I cubed is equal to t sub I squared divided by t sub e squared times r sub e cubed, right? And I am going to raise each side here to the 1/3 power, right? I can do that, right? And I get r sub I is equal to t sub I which we said that was 410 days squared, divided by t sub e, 365 squared, times 1.5 times 10 to the 11th cube, and take all of that to the 1/3 power. And good thing we got our calculator along here. And if I plug all of this in, making sure I got all my parentheses in the right spot and everything, I get that r sub I is 1.62 times 10 to the 11th meters, right? Or if you would prefer, 160 2,000 million kilometers. Either way. Oh, nope, that's not right. That's too many zeros. Is that too many zeros? Well, anyway, this is our correct answer here. That would be 162 times 10 to the 9th meters, which would be 162 times 10 to the 6th kilometers, right? So that would be right, 162 million kilometers. Anyway, that's just so we can get an idea for it. This is the correct answer right here. So, all right, Kepler's third law, Icarus. And for your reward, another adorable picture of my dog, Raven. Oh, cute pictures. Oh. Nice work, physicists. These physics problems are rough.